Force of gravity, 19. Which gravitational force exerted by Earth has the larger magnitude? That exerted on an apple, or that exerted on a sack of apples? Many apples. Which gravitational force exerted by the Earth has the larger magnitude? Well, where's my pen gone? There it is. Okay. We know that F is equal to mg. So the larger the mass, okay, the larger the inertia, the larger the force. So for a single apple, the force will be a certain magnitude, whereas for many apples, a sack of apples, the inertia will be larger, so the force exerted, the force of gravity, will be larger. Okay? So it's larger on the sack of apples that has a larger inertia. Okay, alright, that's nice. What about B? How do you now reconcile your answer in part A? With the observation that when they are in free fall, the apple and the sack of apples have the same acceleration. We've just said now that for a single apple, or for a bag, okay, there's a bag of apples. Okay? This one, there's a larger force of gravity, Earth on apple. And if we draw that one, force of gravity, Earth on the sack. We said that this force is larger than this force because the force of gravity is proportional to the inertia. Okay. Now it says, but now how is it possible that both of these have the same acceleration, g? How is it that they have both the same acceleration? What's your answer for this? What do you think? Well, because if we consider this equation, g is equal to F over m. So, if we say g is equal to F, let's call this, g EA, this one, over m of a single apple. We also have g is equal to F g of the gravitational force on the sack of apples divided by the inertia of the sack of apples. What we'll see is that even though this force is larger than this force, this mass, this inertia, is larger than that inertia. So the ratios are still the same. The effect of the larger inertia cancels it out. Okay? I hope that makes sense. 20. An object at rest has zero acceleration. Does this mean that F equals to minus mg does not accurately represent the force of gravity exerted on the object? Saying now, okay, well, we have an object at rest on the floor, for example, and it has zero acceleration. Right? It's not going anywhere. It's zero acceleration. Now you're saying, but okay, now what happened to this guy? F equals minus mg. I thought this guy was meant to accelerate. Well, this only refers to the force of gravity acting on this object. So if it's in free fall, then it accelerates with this g, minus g. Okay? But what happens if there's another force acting on it? Force of a contact force, the force of the floor on the object. Well, if that's balancing that, then surely our acceleration is 0. Okay? Alright.